Hey everyone, this is Evgeny and you're watching another video in LangGraph Introduction series. Last several lessons we went through different concepts about long-term memory. So we watched how to create a single object, we took the profile, the user profile, then we went through the technique where the list of objects or simple strings were saved as instructions for the model. And finally, in the last lesson, we checked how we can store the list of more complex objects and even use the some insights from tool calling from Trustcall. And today we will try to accumulate all this knowledge together and create something really useful. So let's dive in. All right, so what we are working on today, I guess in general you expected me to talk about something like to-do list, but this is a bit of obsolete and a bit boring for me at least. So I would prefer to take a look at development, and we are trying to create a mentor agent which would help us to work on the code, to think about that, to give us advices, and the most important, remember about our decisions and remind us where it's necessary. So welcome, Dev Mentor Agent. And in general, again, I'm just repeating myself, we are trying to accumulate all the previously gathered knowledge in the one object, in the one application, and in this agent. And in general, the way we are going to work, we would have three types of memories. Here, all of them are long-term, and this would be the dev profile, and it's clear, right? This is a user profile, a single object. The next level up would be our, it says feature task, but in the practice this is instructions. No, it's the way around, but anyway, from the easiest to the more and more complex. The easier one would be dev profile, a single object where we keep all the data about the user. Level up would be instructions, and this would be the list of strings practically that would guide the model to behave in the proper way, in the proper direction, talking about our preferences maybe. And the most complex thing would be architectural decision records, or maybe decisions or something else. So this, the practical information that we are saving to the agent, and we want this agent to stop us when we're doing something wrong against this RDR document, for example. And the way it will be working, we are using this reasoning node, and the way it would work, we have a user input and it goes to reasoning, and then it could be that the information is general one and our dev mentor agent can just respond with the proper answer. Or it could be that it's an information update and we have to update one of our memories. So it's a dev profile, RDR, or instruction, and then it goes back to output, but practically it goes back to reasoning. And if it circulates here until the information is persisted, stored, updated, and then the model will generate a response and provide it back to us. And while answering us back something, the model will be taking care and keeping in mind all this information that was previously stored about user. So that's the idea, and let's take a look at the implementation. So in general, I have this agent already implemented, and maybe we start from the finish, right? So let me compile it and show you how it looks like in real life. And this is what's happening here. Take a look. We have a start, and then we have this reasoning node. It's dev mentor, the main node of the application. And then based on different conditions, this node can decide, okay, there is a need for updating profile record here. So I go here and then goes back. Or dev mentor can decide, okay, there is a new instruction. Maybe you have to update the instruction, remove it. And then it goes here. It's popping up all the time. It goes back again, or it could be architectural decision record, a new one. Again, that's the same stuff, right? It's a list of RDRs, and it could be a new one, an existing one, or a remove maybe one. Or our dev mentor can just simply respond back to the user providing some help. So this is the raw idea what we are constructing today, and this is how it looks like the real one already. And now let's go and look at that step by step. So what do we have here? First of all, we need to define the main node, this reasoning one that has control over everything. And we start from the system message And the important points here are that we are providing that there are 3 types of memory. So this node is aware of that. The agent is aware of that, right? And then we are trying to restrict the model to the specific area of answering. So we are saying that you have to strictly follow architectural decision records. And if something goes against that, you should not suggest it. And also you should respect all instructions because they describe how the user wants you to communicate and assist. And and the final one about the user profile, you should adapt your tone and suggestions based on this user profile. And in general, it could be, for example, a technology like Python, Java, something else. It could be a level of expertise. For example, if you're a junior, it's one type of answers, right? If you're extremely professional in somewhere, well, probably the tone should be very different from the model. So this is the idea. And so then we have to provide all this data. So we do have a dev profile. This is a placeholder we'll insert it later. We have our RDRs, records, and we do have preferences. Well, preference is a second name for instruction, and they kind of equal in scope of this agent. Right, and we are saying that, okay, for decision records, we want to see some extra information on top, and we will take a look at that later. So this is the system message, and again, we are working on the main reasoning node, and this is system message from it. And this is the tricky part, right, because if you scroll down to the model here, we are now on this area, so dev manager should be aware of running different updates, and it should be able to make a decision which update should be taken here, right? And for kind of formalizing it, for making it more clear to the model, because again, this is model, right? It's a model who will be deciding which node should be taken. Maybe it should go to the end with proper response. And to formalize that, we are defining a new model for that. Wait a second, let me scroll up. So we're defining this update memory. And again, the important point here that you have to provide some explanation or description for the model. So we are saying, okay, which memory to update, and we are saying that you are allowed to provide back user, RDR, or instructions. And practically what means it works with combination with our system message. And it's kind of when model knows from the system message that, okay, there are 3 types of memories. And then we are saying, okay, but then you have a tool, specific one, that if you have a feeling based on the system message that a specific memory can be updated, so you have to call the tool, right? And the tool itself says, okay, you have these possibilities, which memory to update, and it's described above already, so model is aware of that. And so the model is capable of extracting this information from the user request and make kind of a tool call. And this is our schema, but we learned already that tools are not always like real practical functions. You perform something like when we're working with Trustcall, we also know that, okay, Trustcall takes a schema as a model, as a tool, and this is the normal way like how models are treated, schemas as well. It's a tool for them, so they know how to execute it in a meaning that extract information and put it into the schema based on the descriptions. All right, so we have the system message, we have the schema, and we do have the node dev mentor. And what's happening here, take a look. We need to fill these 3 placeholders, so we are preparing our profile. And it's you saw it already, we have the storage, the long-term memory, and we get the dev profile, user ID, and profile object. So we're generating it here. Then we have a list of RDRs, and also we generate them as a single text flow, like everything in one place, and the same with these preferences. And then we generate in the system message and just putting this information to placeholders. And you saw it already, it's all there, right? And after that, we have the model, which is a normal OpenAI in this moment, nothing else. And we're binding a tool, which is update memory, which is our schema. And again, what's happening when we make this invocation, we have an update memory tool, schema, kind of, and then model can decide, okay, that what user requested, it's more an area of responsibility of this tool, update memory. So the tool call will be performed. What you have to remember about this technique is that there is a possibility that a model would respond not with the real reply, but with a tool call for update memory based on the context. And this update memory can have user RDR or instructions, like kind of signaling which kind of update should happen. So this is a very important thing. Since we have several options where to go from here, we have to create a route, and I'm doing this kind of I'm not grouping similar functionality in all places, just for your better understanding. So next logical thing would be routing, right? So where to go from this node. And it's pretty simple. If we don't have any tool calls, we go into the end node, and which means that model generated the answer in text for user, and we are just finishing our execution flow. But if it's a call, it's a tool call, then one of three updates can happen. And then based on the update type, and update type comes from the update memory here, and it can have user RDR or instructions. And then based on that, we are redirected to three different nodes. That's pretty simple, right? And that's how this one happens. We can see it here. So based on the tool call, we can go either to the end and finish the flow, or we can grab one of these three flows and update our long-term memory. And now we have our reasoning node. We do have a routing from it, and it's time to define our three nodes that will be responsible for updating different type of informations. And again, as I said previously, we are going from the simplest to the more and more complex updates, but all three of them are sharing the same system message. All right, and next node would be our profile, the easiest one, a single object. So we define our model the same way as we did like 2-3 lessons back. And we have a name, we have a language, framework, and experience level, and the preference, and some explanations for the model, right? So what's happening next? We are creating an extractor from Trustcall. We are providing the model, and we're providing the tool as dev profile. So Trustcall creates it knowing the schema and knowing how to extract the information from it and return it back. And we have this extractor, profile extractor. It's pretty straightforward, I would say. The same technique we saw already. Maybe we should start from here, right? We need to call the profile extractor and provide the current message, which we need to extract information from. And also we are providing the already existing profile. And this one, we're just grabbing from the storage. And finally, we are saving back our user profile, and this is interesting technique because from the graph's perspective, it was a tool call, and so we have the whole node was working as a tool call, so we have to return back something which kind of tool call returned us. And so we are just simulating this call. So we go in messages, the role is tool, and we have the tool call ID, which is important for consistency. We are providing what we get from the caller. And as a context, content of this tool calling, we just saying, okay, the profile was updated. And practically, then if you remember, it goes back. It should go back, not goes, but it should go back. You haven't seen the graph yet, right? It should go back to the reasoning node, the main one, and then as a result of this tool calling would be that, okay, the profile updated. Next thing we have is a list of instructions, and practically we are trying to repeat the same thing which we already did for the profile. The only difference here is that we have a list of strings, kind of, right, where every string is an instruction. In general, we are doing exactly the same thing. We have a schema, it's our instruction, we provide specific explanation for the model, what's that, what should be stored, which way, how to perform, etc. The same thing we create in our specific instruction creator. For Trustcall, we are providing the model, we are defining the tool as an instruction, and we are enabling inserts in this time because, again, this is a list of objects which allows the Trustcall to update the existing ones, to create new ones, to remove them. Okay, and we do have the second note about update instructions. So what's here? It's again, we have the system message, it's the same Trustcall instructions. The same technique, we are gathering the messages we have already, and the system message plus the latest one from the list. from the conversation, because this is the only one we want to analyze. And the same technique, we are returning back pretending it was a tool call, so this time just content is different. We are saying, okay, instructions were updated. And the most complex one, we have this architectural decision records. And again, we're starting from the same thing. We are defining a schema. And this one, this one is a more complex object. So we have a decision, we have a date. I mentioned that briefly, that we want to save the date here, so we know when the decision record was taken. We have some reasoning why it was done here. We have some consequences, like what's possible, what's not because of this decision record. And we do have a statuses, because, well, we want to keep an eye on that, right? Because if you think about that, it's pretty logical, right? If architectural decision record or decision is obsolete now, you don't want to remove it, because in months' time or somewhere, some other person could come with the same idea and you kind of losing your time, right? It's much better approach would be to have the decision record saying that, okay, we thought about that in the past, now it's obsolete or now it's rejected. There is no way how we discuss it again. So it's kind of, that's why we need this status here. And again, for the model, we are providing all the descriptions here. And since this is a more complex list of objects with a specific structure, we're also providing here a tool listener, because we want to provide additional information about what exactly was changed, which way, and we saw this technique in our previous lesson. And in a pair, to work with tool listener, we have this extract tool information, and the idea would be that we provide tool calls that we get from the tool listener, and we format it in a way, readable way, good to consume, and then we sending it back as a result of our tool calling. And then we have the node. And here's more or less the same, right? Take a look. We have created an extractor with model with tool decision record this time. It's still list of objects. So we enabling inserts and we add a listener at the end. So what's happening next? We're making a call. We are persisting the result in our long-term memory. And then we are grabbing the tool calls from our listener and format a summary. So this time we are pretending return back from a tool calling, but as a content we don't have this very short explanation that something was updated or somewhere changed, but we are returning the summary which contains details of this tool call and details we get from the listener. And again, we saw this in the previous video. If you're missing this information, check it. It's a really interesting technique here. And well, practically that's it. We have to build our graph, and so far we had the reasoning, we have 3 update nodes, and it's pretty straightforward, right? All right, I hope you're not sleeping listening this very long story about the graph, and it's time to give it a try and check how it works. So what I'm doing for that, I'm defining a new configuration for the user, I'm defining new threads, I'm also defining several helper functions. So just to be sure, what I'm doing here, I have the send messages, prints the results, and I have 3 helper functions to show the dev profile, and it taken from the memory, from long-term memory. We have the same for decision records and the same for show user instructions. So we can just quickly check what we have there. All right, and we start our conversation with the initial message, kind of saying who I am, what I'm doing, what I know, what I don't like, what I prefer, etc. So it's here, I'm Evgeny, and the interesting thing, it's a Python and LangGraph, and I'm learning how to build AI agents, which is really the case. And I appreciate some broken down devices, smaller steps, practical examples, and so on. And well, this is my focus about, like, I want to understand best practices and trying to improve my skills. And I'm running it. And what do we have here? Take a look. We have the user message. Then it was a tool call. The reasoning node decided, okay, this is mostly about user, right? The information should be updated. So it reacted with the tool call update memory, and it set update type to the user. And because of that, our routing mechanism moved it to update profile node. And again, the node pretended it was a tool call. That's why we see this tool call message, and the content of the whole tool message was updated profile. But in reality, we know that profile was updated, right? And then it went back to the reasoning node, and it responded. At that time, it thought, okay, everything is fine, and it just created a response like, great to meet you again, it sounds like you're on an exciting journey, and so on, right? And the whole route finished. And if I check what we have in our dev profile, we can see that, okay, what information was extracted? Okay, the name is here, language Python, framework, LangGraph, experience, I'm learning, and some of my preferences. And this information will be taken into account on the next calls, right? But we continue in our dialogue, and I'm trying to create a decision here. So what we've decided that this is a learning curve, and we don't want to introduce real databases we use in-memory stores all the time just because it's easy. You don't have to run any databases, you don't have to solve problems, connectivity, losing connection, something else, right? That's the decision for my path, right? And I'm trying to provide it to this thing. And what's happening here, take a look. It realizes, okay, it sounds like architectural decision record, right? And so the specific node was introduced or triggered. And this node generated this beautifully readable result, right? So we have date, we have status is active, and some consequences. And as a response from, it went back to the reasoning node, and the node responded with, okay, I've recorded your decision to use in memory stores, because it saw that the tool call happened, and the result was that the new RDR was created. And if we take a look at our decision records, what we have in long-term memory, we can see it's there already, right? So we have a date, and this one is real, and we have the ID, which is unique and was created on insertion time, and status is active. Okay, my next message will be pretty long one, so I'm passing the whole chatbot, and this one about chatbot long-term memory from our previous lessons. But this is the idea. I'm kind of trying to communicate with this mentor, and I'm saying, okay, well, you know, this is my chatbot, and can you show me how to save the conversation history here, right? So I'm running it. We can see our code, and let's make it scrollable. And what do we have here? Let's take a look. See, immediately after my question, it was a response from my iMessage. So it was not about updating anything here, right? It was a reply immediately. And I'm not gonna look into it, but what I wanted to say you, like, it's a lot of text here. For me, it's a verbose, and I'm confused, like, completely. So that's the proper time to create a new instruction for the model. And I'm saying, okay, that explanation was a bit too verbose and confusing. Please, from now on, start with a short summary before the code and keep explanations clear and concise. And, well, this time, the reasoning node realized, okay, this is about instructions. And so the node was triggered, and the instructions were updated, and it went back again to reasoning, and the reasoning responded this time. Okay, and I think it just repeated their answer, but now it provided a summary the way I asked before, right? And then we check all the instructions we have at the moment. We have a single one that was just created. So start with a short summary before the code and keep explanation clear and concise. And now let's try to break the system. So it's interesting, we have this chatbot long-term memory, and it saves something to long-term memory, and I'm asking, okay, I want you to change the code so it saves everything to SQL database, not keeping it in history, in the memory anymore, right? And I'm running it, and look at that, what's happening? It says, okay, but since your current decision is to use memory stores for agent memory, I refuse doing that, man. That's interesting, right? And let's assume it was far away in the past, and I'm saying, hey, I don't remember when was the decision made. And then AI responds me immediately, okay, the decision to use in-memory storages was made on June 8th, and the reasoning behind that was this and that. But if you want to change this decision, just let me know. And this time I'm saying, well, yeah, you know, actually I think it's time to enable real databases. So the previous RDR is kind of obsolete. I don't like it anymore. And this is my clear decision. And what's happening here, I'll take a look at that. It's another change about architectural decision record. The model realized that. And we have a new RDR here, which says we need to use SQL SQLite database, right? And it was some summarization from my AI agent. So if you take a look at all the records here, now we have two, and take a look. This one was created, right? Use SQL database. So it was a decision that we created recently. But the previous one was updated as well, because it's still here. You can read it, right? You can understand what was the reasoning behind that, but status is obsolete now. So it's here, it's visible, but it's not taken into the account anymore. And by the way, I think if you scroll up down here, you will see that the code was updated in a way like SQL database is used, right? And maybe you want to check, it's obsolete, it's not active anymore. We can ask, like, can you show me a list of all actual decisions you have so far? And then the model would respond you, okay, it's the only one about SQL databases. So the one that's obsolete was ignored. And you can do the same, by the way, with your current preferences. Like you can just ask, show me my current preferences or your current preferences. And we do have two here. All right, I think that's enough for now. It's a pretty long video already, and maybe you titled already as well. But in general, you saw the more or less real example how you can create your own AI agent, the same, almost the same as Cascade, maybe, or Cursor, I don't know. But it would really help you. It would keep a lot of memories about your work, about yourself, about different RDRs. It follows the instructions you defined. It can tell you when a decision record was created, etc. So it could be a really helpful guy sitting next to you and keeping an eye on what you are doing. And it was Evgeny. Thanks for watching this video till the end. I really appreciate this time. I really appreciate it because it's a long one. And I will see you next time in the next talk about LangGraph introduction. See you and bye-bye.